All right, so today we're looking at sum of a series, and the following standard results can be used to find the sum of many series. So number one is the sum of the first n counting numbers. That is what number one is saying. The sum, that is this one here. The sum of the first n counted numbers is equal to n into n plus 1 divided by 2. Number two, the sum of the square of the first n counted numbers, the sum of the square of the first n counted numbers is equal to n into n plus 1 into 2n plus 1 over 6. And the sum of the cube of the first n counted numbers is equal to n squared into n plus 1 squared divided by 4. Now, 3 would be easy to remember because literally 3 is just the square of 1. All right, summation. So recall the summation laws. So these are your summation laws that the sum of the first one, sigma from r is equal to 1 to r is equal to n of c is equal to n times c, where c is a constant. So in other words, if you see sigma from when r is equal to 1 to r is equal to n of a constant, what it's saying to you is that you must multiply the constant n times. So for example, the sum of 2 from r is equal to 1 to r is equal to 15 is 2 times 15, which is 30. Now, the sum of c times a sequence or is equal to, or the sum of the terms c times a sequence is equal to c times the sum of the sequence, where c is a constant. So for example, the sum of 4r is equal to r times the sum, is equal to 4 times the sum of r. Summation results 3, the sum of UR plus VR is equal to the sum of UR plus the sum of VR. For example, the sum from r is equal to 1 to n of r squared minus r is equal to the sum from r is equal to 1 to n of r squared minus the sum from r is equal to 1 to n of r. Note, and this is important, there is no rule for the product or quotient. There's no rule for the product or quotient. So very, very important to note. Example 4. Example 4 is asking you for the sum of the first 25 counting numbers. Now, this is your formula. From r is equal to 1 to n of r is equal to n into n plus 1 over 2. So therefore, the sum from when r is equal to 1 to 25 of r, wherever I see n, I'm going to simply replace n with 25. So this would be 25 into 25 plus 1 all over 2. So this would be 25 times 26 over 2. 2 into 26 is 13 times. So this would be 25 times 13, which I think is 325. So this is 325. All right, so the next thing we can do is have a look at examples 5 and 6. All right, so example 5 says, find the sum from r is equal to 1 to r is equal to 30 of r minus 2. So this is actually the same as saying the sum from r is equal to 1 to 30 of r minus the sum from r is equal to 1 to 30 of 2. So using the formula, this is the formula from r is equal to 1 to n of r is n into n plus 1 over 2. Using this formula and replacing n with 30, we get 30 into 30 plus 1 over 2 minus 30 times 2. This is 15 times 31 minus 60. So 15 times 31 minus 60, and this is equal to 405. Example 6. Example 6, this is the same as saying the sum from r is equal to 1 to 40 of r squared plus the sum from r is equal to 1 to 40 of 2 times r. So again, these are our formulas. From r is equal to 1 to n of r is n into n plus 1 over 2, and the sum from r is equal to 1 to n of r squared. I think it's what? N into n plus 1 into 2n plus 1 all over 6. Am I correct with that? Terminal, right? Is it correct? So therefore, what I have here, replacing n with 40, 40 should be here. I'm going to get 40 into 40 plus 1 into 2 times 40 plus 1 all over 6 plus 2 times 40 into 40 plus 1 all over 2. So this is 40 times 41 times 81 over 6 plus we have 80 times 41 over 2. And what do we have? Well, I would say don't stress yourself, just use the calculator. 40 times 41 times 81 over 6. Let's put equal 22140 plus 40 times 41. 1640. Final answer. And we get 23,780. All right, examples 7 and 8. All right, example 7 is asking us to find the sum of the counting numbers from 11 to 25. Now, the formula for the sum of the first n counted numbers is this. from R is equal to 1 to what? N is equal to N into N plus 1 over 2. Now, note this formula only works from when R is equal to 1. So if I want to find the sum of the counting numbers from 11 to 25, using the formula, this is what I would have to do. I'd have to find the sum from R is equal to 1 to 25 of R minus the sum from when R is equal to 1 to 10 of R. Now, in the formula, put in N is 25. We get 25 times 26 over 2 minus, replace in the formula, where is the N, put 10, 10 times 11 over 2. So this is 25 times 13 minus 5 times 11. 25 times 13, I think, is 325. 5 times 11 is 55. And what is our answer? This is 217. All right, 8, example 8 is asking us to evaluate the sum from when R is 8 to when R is 20 of all of that. All right, so for example 8, what I normally like to do is to sort of consolidate this, make this into one formula before I actually do my calculation. So first of all, this would be from R is equal to 8 to 20 of R squared minus from when R is equal to 8 to 20 of R. So I normally just like to add, sort of like work out the formula first. So this is N into N plus 1, 2N plus 1 over 6 minus N into N plus 1 all over 2. As I said, I sort of like to work the thing down to one formula, because if I don't, I'm going to have to end up having, let us say, maybe too much calculation, or I'm going to have 4 sets of calculation to do. Whereas if I do it this way, I'll only have 2 sets of calculation to do. I could multiply the top and the bottom here by 3, and then factor out N into N plus 1 over 6. So I'll get N into N plus 1 over 6. And inside the bracket, I have 2N plus 1 minus 3N. I think that is so. So it's what? N? No, it's not 3N, it's just 3. Thank you. It's just 3. So the formula would then be N into N plus 1, 2N minus 2 all over 6. And this can be written as 2N into N plus 1, N minus 1. All I did was factor out there, and this is over 6. This cancels this 3. So if I want, I could say N into N squared minus 1 all over 3. Because N plus 1 times N minus 1 is N squared minus 1. Now that I have the formula, I could say that this, which is from 8 to 20 of R into R minus 1 is equal to, sorry, I shouldn't put back this. That, yeah, I could. From R is equal to 8 to 20 of R into R minus 1 is equal to, from when, well, this is the formula from for when R, starting from R is equal to what? 1. So it must be from when R is equal to 1 to minus to when R is equal to what? 7. So first replace N with 20. So we have 20 into what? 20 square minus 1 over 3 minus to when N is what? 7, which is what? 7 into what? 7 square minus 1 over 2. So let's see what these come out to be. 10 times 20 square is what? 400. So this is 399 minus 7 times 48 divided by 2 is what? 24. Let's see what this comes out to be. So 10 times 399 minus 7 times 24, and we get 3822. So thank you for that correction. So let's fix it. This should be 3 here, not 2. And then everything down here is going to be wrong. And 3 here as well. So this is 3 here, 3 here, 20 times 399 over 3 minus 7 times 48 over 3. And let's see what we have for our answer. And our answer is 2,548.